Strings are a special type. They are immutable. This is because string is an immutable class, which means that once you create a string, you cannot change the value of that string. If you assign a new string value to the same variable, a new object gets created, and the variable now holds the reference to this new object. This can be beneficial because it allows you to use string objects in a thread-safe manner, without having to worry about another thread modifying the string while you're using it. Okay, we have not seen threads yet, but this will make more sense later. Let's prove that this is how it works, right here in IntelliJ. I'm going to create a string s1, and I'm going to set it equal to hi. And now I'm going to say string s2 equals s1. So s1 is also going to get the value of hi. And then, just to make sure that this is what's happening, I'm going to print both s1 and s2 separated by a space. Alright. And now I'm going to override s1 with a new string hello. If the string were immutable, then right now, if I would print it again, s2 would also have changed, because I've set s2 equal to s1. So let me go ahead and print this again. Another space and plus s2. Alright, let's run this. As you can see, the first time we get hi hi. The second time we get hello hi. This is because the string object is immutable. A new object gets created instead of overriding the value on the old object. Let's contrast this with a mutable object. For mutable objects, the original object gets altered instead of creating a new object with a new variable. I have created my own type here, and it's called text. Text has a variable description of type string and is a private variable. I have created a getter and a setter to access and modify the variable description. Let's see how this is different right here. So I'm going to create one text, call it T1, I'm going to say new text. On T1, I'm going to set the description, well, let's make it high as well. And then now I'm going to create a text2, and I'm going to set it to T1. And I'm going to do something similar. I'm going to print both. So I'm going to say T1 get description plus a space, and then I'm going to say T2 dot get description. Alright. And now I'm going to do something similar as I just did. I'm going to alter T1. I'm going to update the description. I'm going to say set description, and I'll make it hello. And then I'm going to copy this line and do this again. And what you'll see this time is that both the ones have changed to hello, because we're looking at the very same object in the memory here. So let me run this again. As you can see, the second part I get another hi hi, which is both for T1 and T2. After updating T1, both of them are hello. Let's make sure that this is clear by drawing the memory of what is happening for both scenarios. So let's first look at the immutable string. So here we have the code snippet. We have string s1, we set to hi, and then we set our s2 equal to s1, and we update s1 with hello. Here's what's happening. In the first step, we create s1, and an object on the heap gets created, and we store the reference to this object on the stack in s1. On the next line, we set s2 equal to s1, so s2 is holding the reference to the same object on the heap. In the next step, we're actually creating a string hello and make s1 point to the string hello. But as you can see, s2 is still pointing to the original object, which has not changed. Hence, we get hi and hello in the outputs. And this is what's happening for text. We start with creating a new text field, and the description of type string is then null still. What we do next is that we update the description to be hi. So the description on the object on the heap is actually pointing to another object on the heap. In the next step, we set T2 equal to T1, so both T1 and T2 are pointing to the same object on the heap. And finally, we update that object on the heap to hold another value for description. As you can see, a new string gets created, and the object on the heap is now referencing to this new string object with the value updates in this situation. And as you can see, both T1 and T2 are still pointing to the very same object, even though that object is now pointing to a new object. And this means that once we go and ask for both T1 and T2, hey, what's the description? They're looking at the very same object, they're holding the same reference, and of course, the description is then going to be the same thing. So if one of them changes, both of them changes, because they're actually looking at the same object still. Alright, now hopefully we understand how immutability works. It's tough, don't worry if you understand it for like 80% at this point. It will come, I promise. Having done this though, it's time to talk about comparing strings in more detail.